Hi, welcome to another video on my Arduino Mega2560. Again about pulse width modulation. Last time I did some simulation using Scilab and Xcos and tried pulse width modulation. I have dived some deeper into it and actually found out that this CCPWM stands for Capture Compare Pulse Width Modulation, and when you run the simulation it actually shows a blank line at -5. I don't want this, so let me end this. See the block parameter, which is -5. Let me put it to +5 and see what happens other than being suddenly at +5, which it is not. So this is not a solution. What I want to do is see, apart from this, see what the motor does do it on it, and I take a motor for it. So let me go to components and take an actuator. Then connect this actuator to the motor. Then I think I need another ground. And from here I need a sensor, and I think I need to go here for a speed sensor. Then I need an interface to convert it to a real output, and then a C-scope, just like above. And a timer device, but that will be a source from probably, yes, that looks like it. And this one is called scope 1, so let me call this one scope M, because we're dealing with a motor here. So let's just see if this is giving a different signal than this one. I can only hope. Let me, for security, save this into 3. Yes, and see if this actually works out somehow. And wow, there is some, it's not a completely blank line anymore. This is, but this isn't. So there is at least some improvement. And mind you, this is of course the speed that I'm measuring. And then, oh, I can't do that. I have to stop the simulation. So this is amplitude of 5. Time for one period is 1. If we take a time for one period is 10, what will it do? And this is 5 volts again. Here there's nothing, so let's save this and run again. And then I'll have to close this one and close this one. Go. Not much difference. Alright, let's see further. So, adding a DC motor to a pulse width modulation with a signal voltage and a speed sensor, it gives me something like a ripple. What is the really? Okay, time for one period is 1. So let me change the time to 50. What does that do? Is it of influence? Let me exit here and exit here. Go. Yes. There's no change at all. So I remember one of the former simulations, I did have a very nice graph from the motor and speed. So the question is, how did I do that? What was this again? 5 volts. That is okay, considering the voltage of the Arduino. I can't change. Can I change this again? Yes. Number of bits, but I don't think it's really important. And this time for one period. Considering the complete same ripple from that value, I think this is not the way to go. What is the way to go then? I'm afraid I can't say, because I simply don't know. If I read about compare and capture, then I would expect more entries. The same, by the way, when I look at space vector pulse width modulation, but I'm getting strange errors in that. Apart from that, the settings here are a mystery to me, so I leave this out for now. It has one condition, one other addition, namely the clock. For the rest, I leave it out now. And with this, I guess I should get back to the real circuit and see what this is going to be or bring, because if you want to simulate a pulse width modulation motor, then you should have one, and not just any DC motor. So, using pulse width modulation with a DC motor, what does it bring? I have to find that out. Is this better? Or is, for instance, let me go here, a constant better? Or is a sine better? Those are intriguing questions, and I of course can check this. Let me check for the constant and quickly check. The ripple has gone, or it's barely a ripple right now. So that's one thing that is a change. And if I remove this in favor of a sine, although wait, this is a sine with, this is a constant, which I should get at 5. What does this deliver? Somewhat bigger, but by far not the same as not what I expect. So I leave it at that for now, and I go back to the real circuit, see what I can do there. When looking at the real circuit with two functioning propellers and motors, that's another one, and that is another one with a chain. Focusing on the middle of the screen, you will see that there is right now just one LED. The right one, and well, it's the only right one right now, literally correct one, because the left side one has broken off, unfortunately, and the middle one has a problem with its contacts, so that it didn't matter whatever happens, it didn't function properly anyway. So right now there is a piece of metal, well, pin stuck in here, so I have to somehow remove it. Ouch. But what I want to do now is change the frequency of this one. See if this actually is influenced, as I think it is. It flashes upon this upon touching the switch, but can I indeed with pulse modulation visibly change the flickering of this LED? So off camera I'm going to change the frequency, which is called the prescaler, from 120 to 40, and see whatever change that may bring. And that is a very short thing that I have to do, and you see that everything stopped, went off, and then, well, as you see, it just keeps on flickering. So apparently, well, what's the change between 40 times a second and 120 times a second? Yeah, it's a third. But is it really visible for the naked eye? On the other hand, I can do it differently by maybe changing the frequency that is visible for for the eye. So let me see if that is obtainable. Then it won't be working for the motors, since the range is 40 to 120, but who knows. And for that to know, I have to use another paper again, which shows that I have to use a different prescaler, which is 5, which is 30 Hertz. So changing the prescaler from 120 to 40 is, I think, no use. And I did it wrong because it's still on prescaler 4, and that's obviously no change. So now I have changed it to prescaler 5 for 30 Hertz. Compile and upload. And now you see a clear change. A very clear change. The flickering is quite a bit lower, and a very clear flash upon hitting on the switch. So that's a direct influence of the pulse width modulation. What I can also do, of course, is use prescaler 6, which should bring the frequency back to smaller than 20 Hertz. And then it is, of course, which frequency is it? I don't know, but let's see what effect that is. Compile, upload, and I don't see anything except for the running motor. Nothing is happening anymore. So let's bring it back to prescaler 5. Compile and upload, and there it goes. So that's a nice experiment. It needs at least this circuit needs at least prescaler 5 of 30 Hertz to actually do work. That's an interesting experiment. Because it also means that apparently these motors work on a frequency lower than 40 Hertz. I think. Assuming that this information is correct, of course. But lower than they do stop. It's 5 volts, 30 Hertz, and they work. But now is the question, can I also with the software without changing the pot meters really influence the frequency. That's an interesting thing. Anyway, this is a nice idea. This doesn't do anything. It doesn't do anything at all. I should take care of that. This circuit is indeed led from this one, but then it is very different, because although this LED has gone, this wire and this wire make sure that this LED is still on it. But it doesn't do anything. Well, it should be flickering like this. So that is a little bit odd. What would happen if I change this wire and connect it here? That's an interesting one. That is a very interesting one. So, yeah, let me do that. So, in order to accomplish that, I remove this white jump wire and I put in a shorter blue one, and that should be exactly there. And now it indeed shows the exact same behavior as the green one. So now these two have the exact same behavior. Let me turn the light away for a moment so you can really see. So that's one thing. Now another obvious thing is that if you look at this LED, it doesn't really behave the same. So that means that the frequency is different. And yet again, all the frequencies that come from here are the same. So that's something I still have to investigate. Anyway, this was a nice experiment with the frequencies and the prescaler, which is the same, by the way. So from this resistor with the inverse working of this one, it just kept doing it. It just kept burning. So that's curious and odd. And for the rest, I have to look into that. Yes. Anything else to do? Not really. Not for now. So, yeah, I should see into programming an adaptation of the frequency, but I'll leave that for another time. I think this is a nice result despite the weird outcome of the simulation, which I have to investigate further as well. And unfortunately something in the breadboard that I have to fix here. How do I get it out? I have no clue. For now, thank you for watching. If you like this video, please consider to support my blog and videos where I allow advertisements in between the video segments. if you don't want to do that, please visit my website, which is mentioned and shown under this video, for another way of supporting my blog and website and videos, and for much more projects that I'm working on. And this is to be continued.